Welcome to the Quick Terrain Modeler Photogrammetric Drone Getting Started series. This is a three-part series that will discuss the tools and methods in Quick Terrain Modeler to analyze, edit, conduct QA/QC procedures, produce products, and share data to meet your photogrammetry needs. In the first video, we will cover photogrammetric derived models, a quick overview, and how they differ from LiDAR. In video 2, we'll learn how to take your raw data and turn it into a finished product. We will cover Quick Terrain Modeler's cleanup and editing tools, the georegistration process, and DEM and DSM creation. And lastly, in video 3, now that the data is cleaned up, what can you do with it? We'll cover profiles, change detection, and volumetrics. Previous Quick Terrain Modeler tutorials have focused on LiDAR exploitation. However, LiDAR can be expensive and time-consuming, especially for small companies evaluating areas with a small geographic footprint. A strong complementary technology called photogrammetry uses images or video from a drone or UAV to derive point cloud and surface model data, often used in mining and logging for measuring pile volumes or environmental events to evaluate flood and erosion effects when a large manned system may take too long to position. Photogrammetry is becoming more and more popular. Photogrammetry-derived 3D data is produced by overlapping images, much the way your eyes work. Seeing an object from slightly different perspectives yields depth perception. Multiply that by many images and many pixels, and you get many 3D points. Other names for these products are passive 3D, photogrammetric-derived point clouds, structure from motion, and EO3D. Once the images have been processed into a point cloud or a surface model, Quick Terrain Modeler can quickly and easily perform all the functions and analyses as it does with LiDAR-derived point clouds. The primary difference between photogrammetric derived models and models from LiDAR is that LiDAR can often see through tree canopy because the emitted laser receives several returns from each pulse, thereby creating a layered effect you see on LiDAR models. Photogrammetric derived models can't do this, so areas under the overhead cover will appear as holes in the model, which makes it more difficult to create a good bare earth model. A quick look from underneath the model will highlight this effect. Point cloud models derived via photogrammetry, like some LiDAR models, have RGB colorization inherent in their spectral information. This is what gives the model the real-time look, but this can be toggled off and each point can be colorized based on other information such as absolute elevation or AGL elevations. In the next video, part 203 in this photogrammetry drone series, we'll discuss how Quick Terrain Modeler can help if your drone model isn't georegistered or the georegistration is off. Additionally, we'll discuss cleanup and editing tools and creating DEM and DSMs. See you in part 2.